Welcome back. We are now at lesson 28, perimeter lesson, homework review part 2. Part 2 again. Please, if you can, leave a like for the video if you find it helpful, and subscribe to the channel if you have not done so already. Channel notifications will be to let you guys know when new videos are added to the channel. All right, and I'm gonna give a shout out today to two of our Algebra 2 honors teachers we have that you guys are probably looking forward to seeing too. One is Miss Lovastik, and 2 is Miss Kopek. Both those ladies are tough. They're gonna make sure you guys get through Algebra 2 and really learn your stuff so get ready for high level math. So shout out to those ladies. You know, they're working hard. My coworkers and all, and hopefully, guys, when you do have them as a teacher, that you guys will be really enthused to do your best. Okay, so here we go. We're at question number 3. We're triangle ABC, which is at -4, -2. So I'm gonna plot those points, if you will. So -4, -2. So 1, 2, 3, 4, -2, 1, 2. I think that's where I go. Okay. And then we have -4, 8. So +4, 8. So you have 1, 2, 3, 4, and +8. 1, 2, 3, 4, 5, 6, 7, 8. So that's 4, 8. And then C is 7, -2. So 1, 2, 3, 4, 4, 5, 6, 7, -2. 1, 2. Oh, all right. There you go. That's actually pretty helpful. All right, so here we go. We're going to label these points, all right? And so this was point A at -4, -2. All right. This is point B at 4, 8. And this is point C at 7, -2. So it's a good idea in this case to label your diagram, and then of course we connect the segments. All right, so again, use a straight edge. All right, so and what we're going to do now is we're going to find the perimeter of this triangle by adding up the line segments. Now, the easiest one to find will be, in this case, be able to find the measure of AC, which I'll just kind of move up a little bit here. Oops, wrong one. Okay, that's not what I want. All right, let's move back, hopefully. Yeah, okay. I think that's where it is. Is that where it is? All right, so, okay. And so it's this line segment I want to move up. Okay, that's fine. All right, so AC, we count boxes though. So the idea in this case is that we want to figure out the perimeter. So the nearest tenth. All right, so we know AC, we count across. All right, so AC is going to be, here we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So AC is 11 spaces. So this is the easy one. All right. So now what we want to do is be able to find our measurement for AB. Now AB, what we're going to do is use this formula. Okay. So the measure of AB. Now, this formula is based upon Pythagorean theorem. So if you want to, you could drop a line segment from B and go all the way down here, or if you, the line segment, of course, would be a little straighter than mine. You know what? Maybe I will just erase that. And just drop a line segment here. So you could drop a line segment and use Pythagorean theorem. It's the same thing, actually, honestly, because you're just counting boxes. Okay, so here we go. All right, and so, but I'm going to use a formula because I'm a little formula guy, and so we're going to do this. So the following, we're going to now use, in this case, the difference of the x's, which is 4 minus -4 squared, okay, plus the difference of the y's. In this case, is going to be 8 minus -2 squared. Extend this here, and so we're going to get here the square root of. Well, 4 minus -4 is 8, so that's going to be 8 squared. And then we have 8 minus -2 is going to be 10, so that's going to be 10 squared. So you add it together, 64 plus 100 is square root of 164. And because we find the nearest tenth, I'm going to leave it this way. And you say, well, how come, Mr. Kong? Well, because of the fact that we're not looking for the exact value in simplified radical form, just nearest tenth, and which we'll do later on. Now we're going to do the same thing here for BC. So the measure BC is going to be the square root of, again, difference of the x's, which is 7 minus 4 squared. Difference of the y's is going to be negative 2 minus 8 squared. And that's going to give us, in this case, 3 squared plus negative 10 squared. That's going to be the square root of 9 plus 100, or the square root of 109. So now we're going to find the nearest tenth. So we need to add now here. So this was 11. Okay, so this was 11. We found this measurement to be the square root of 164. And this would be the square root of 109. And so let's take a calculator. All right, so I'll bring out the calculator this time. Here we go. And so now we're going to add, in this case, okay, go back to our, make sure we're regular mode. All right, so we have 11 plus the square root of 164, the square root of 164, here we go. And then we'll move this over, and now we'll add by the square root of 109. Now, by using the calculator, writing this all out, we'll find in this case the sum of all this will be 34.246. So we get 34.2465. Okay, so here we go. So we get in this case, so we have 11 plus the square root of 164 plus the square root of 109 equals 30, I think we said 34.2, what was it again? 24, which now, okay, we're going to nearest tenth. So nearest tenth means our answer will be a perimeter equals 34.2. And so this will be our answer here. Okay? All right, ladies and gentlemen, hopefully that was helpful. All right. Now, so we use Pythagorean theorem, or this is formula to find our sides. Let's move on to question number 4. Now, question number 4 is the following. Given the right triangle shown below, which of the following expressions would correctly calculate this perimeter? Okay, so what we can do is call this A, and I'll call this C. And so the perimeter would be, in this case, 15 plus A plus C. But now we got to figure out what A and C are. Well, we use trigonometry. Based upon the angle here, 42, we're going to now look at the ratio sides. So here, A is the leg opposite of the angle, and 15 is the leg adjacent to the angle, and C is the hypotenuse. So for A, we will get the following. We will get the tangent, because tangent of an angle is opposite over adjacent, which is in this case going to give us 10 of 42 equals A over 15. Which means you multiply both sides 15, we get A is equal to 10 of 42 degrees. So we got that part. So we have 15 plus 10 of 42 degrees. And that will get rid of, in this case, choices 1 and 2, because we need 15, 10, and 42. Now we will find C, all right? And so to find C, here, we're going to use the adjacent over hypotenuse. So because we know this measurement, we're trying to find this measurement, we know that's going to be cosine equals leg adjacent over hypotenuse. Or so here, we'll get that the cosine of 42 is equal to 15 over C. And so if we switch out C and 42, we get C is equal to 15 over the cosine of 42. And so therefore, a C value is 15 over cosine of 42. Well, that would be, in this case, choice 4. Okay, so when you're showing your work, because you want to show workliness. You want to show that how you find these pieces. So you want to set up on your triangle the like opposite, like adjacent, hypotenuse. You want to show in this case which ratios you use, and of course filling in them in, and so of course getting each of these quote unquote letters by themselves, A and C, to find your sum. So there you go. There goes your question number 4. Right, we had to use trigonometry for this one, while we use the distance formula for question number 3. All right, ladies and gentlemen, this will be end part 2 for us, and I hope you guys found it helpful. Again, if you found it helpful, please leave a like for the video, and of course, subscribe to the channel. All right, and again, please leave comments, questions below, any corrections I need to make in case I make errors and all, or just whatever topics you would like to see done that maybe were covered in the past, but like another lesson in the case, just a follow-up lesson, if you will. Totally good. I would totally do a video on that as well too. Just give me feedback. Appreciate all that, ladies and gentlemen. Thank you so much for watching. Take care and be safe. Okay.